Okay guys, so we're up to lesson 4 for year 8 probability. In this lesson we're going to look at Venn diagrams. So far we've learnt about single event probability and then compound events. We learnt about mutually exclusive. And in the last video we learnt the laws of probability, the law of multiplication and the law of addition. We're going to start off by talking a bit about sets. We can use a set to group all of the outcomes of a particular experiment. Like this. Here's the set of all outcomes for throwing a 6-sided die. So we can get a 1, 2, 3, 4, 5, 6, and we just list them inside a circle. Now if we have two sets, then they're going to be separate if the events are mutually exclusive. So let's take this set of numbers 1 to 6, and we're going to define the two events as this set is going to be the odd numbers, and this one's going to be the numbers greater than 5. You can see how they don't have any common elements, so we draw them separately. They're going to overlap if the events are non-mutually exclusive. So let's choose the odd numbers for set A again, and this time let's choose the numbers greater than 4. You can see there's an overlap. The number 5 appears in both sets. Now Venn diagram uses sets to organize 2 or 3 events. And it looks like that. So it's exactly the same as what we just did with 2 circles, but it's got a rectangle around it. We're going to use the same sample space, which is the numbers 1 to 6. So we're going to call the events A and B, and they are going to overlap. And in the center, we put numbers that are common to both events, which in this case was the 5. In this side, we write numbers that are unique to event A. Over here we write the numbers that are unique to event B. And the only difference between this and the previous diagram is outside the circles, but still inside the rectangle, we write the numbers that aren't in either event. So see how we've only got 1, 3, 5 and 6? We're missing 2 and 4 out of this. So that goes down the bottom here. So let's try and draw a Venn diagram. Here's our sample space, 1, 2, 3, 4, 5, 6, 7, 8. 2 sets are chosen. Set A is the set of even numbers, so 2, 4, 6, 8, and set B is the set of prime numbers, 2, 3, 5, 7. So let's draw our Venn diagram. So there's the 2 overlapping circles, events A and B. Which number or numbers are common to both sets? There's only one, isn't there? It's a 2, so we're going to put the 2 in the center. Now let's see if we can fill in the rest of set A. So we've used the 2, we want to put the 4, the 6 and the 8 in. Now let's fill in set B. So we've used the 2, we're missing the 3, 5 and 7. In it goes. Now do we have any numbers missing from our sample space that are not in these circles? Yes, we're missing the number 1, so it goes outside. We can also just write the total number of elements in each set. So we could get a question like this. This Venn diagram shows a collection of books and whether they are available on Kindle or as a hardback, both or neither. So have a look at that. There's 10 that are available on both Kindle and hardback, 7 that aren't available on either. So we might get a question like this. How many books are available on Kindle? So don't just count the 5. This one means only on Kindle. These 10 are also available on Kindle, so together we've got 15. Only on Kindle, I just answered that one, didn't I? That's 5. As both is this here, so that's 10. As neither, which is outside the circles, which is 7. We can also answer probability questions about Venn diagrams. So suppose one book is chosen at random, find the probability that it's available on Kindle. Remember, we're going to have to count the ones that are only available on Kindle as well as the ones that are available on both. So we've got a total of 15 out of, we need to add all these numbers up. So this is 10, 20, 25, 15 on 25. What about the probability that it's only available as a hardback? So that's going to be just these ones in here. So 3 out of 25. What about the probability that it's not available on Kindle? So it's not this one, not this one. We want this one here and this one here. So altogether, 10 out of 25. Another thing we have to be able to do is construct a Venn diagram. Let's have a look at that process. In a group of 50 people, 34 of them speak Mandarin and 25 speak Danish. 10 people in the group speak neither Mandarin nor Danish. Construct a Venn diagram for this information. So we're going to start with a blank Venn diagram, which is just two overlapping circles. We've labelled the first one M for Mandarin and the second one D for Danish, and they're inside a rectangle. Now we're going to start outside the circles. Are there any people that speak neither language? Yes, there are 10. So that's what goes down here. All right, now we need to find the overlap because remember, they're not mutually exclusive. So I'm going to add 34 and 25 and 10. So that adds to 69. So 69 people speak Mandarin, Danish, or neither. But how can that be when we've only got 50 people? It's because we've got a double up. So we've got a double up of 19. All right, we've counted this 19 in the Mandarin speakers as well as in the Danish speakers. So this number goes in here. Now let's look at the Mandarin circle. 34 of them speak Mandarin. We've already got 19 accounted for, so we need another 15. Now let's look at the Danish circle. We've got 19 already. We need 25. 19 plus 6 is 25. And now a quick check. 15 and 19 and 6 and 10 should add up to 50. Does it? Let's have a look. 6 and 9 is 15 and 5 is 20. Now add the 10s, 30, 40, 50. Yes. Okay, here's another one, slightly different. In a group of 25 friends, 14 own a cat, 16 own a dog, and 7 own both a cat and a dog. Draw a Venn diagram for this information and find the probability that one friend, chosen at random, owns neither a cat nor a dog. All right, here's our blank Venn diagram. C for cat, D for dog. Now, we would like to start outside the circles, but we don't have that information. We've got 14 owning a cat, 16 owning a dog, and 7 owning both a cat and a dog, so we're going to start here. This 7 goes in here. Okay, so we've got the 7 in here. Now, let's look at the cat circle. Altogether, we've got 14 owning a cat, already got 7, so we need 7 in here. And now looking at the dog circle. All right, so we want 16 owning a dog. We've already got the 7. 7 plus what makes 16? 9. All right, now we need to find out how many own neither animal. And all we're going to do is add these numbers up, 7 and 7 and 9, which is going to give us 23. How short are we? 2. And so we put a 2 down here. Now let's answer the question. Find the probability that one friend, chosen at random, owns neither a cat nor a dog. So that's going to be 2 out of 25. And one more. In a class of 30, students either study geography or chemistry or both. 15 students study only geography, 12 study only chemistry. Draw a Venn diagram. Okay, so we've got G for geography, C for chemistry. Now, this one's slightly different, okay? Let's start outside the circles like we did with the first one. Are there any students that study neither geography nor chemistry? Can you tell from the question? They either study geography or chemistry or both. There's no mention of them studying neither, so there's 0 going down here. You can put the 0 in or leave it blank. Either way is fine. We also don't have a number to put in the overlap. We're told that 15 students study only geography. That goes in here. And we're told 12 study only chemistry. That goes in here. How are we going to find this overlap? By adding up the numbers. So 15 and 12 is 27. How short of 30 are we? 3. So 3 students study both. Now that prompts me to say, read the question carefully. Questions for Venn diagrams can be very wordy and they are sometimes confusing. So make sure you read the question carefully and highlight the important information. Let's finish off with this question. Now Venn diagrams can have 3 events. In Year 8 you won't be asked to construct a Venn diagram with 3 events. You will only have to do that for 2 events. But it's possible we could throw a question like this in the harder section of a paper and ask you to answer questions. So let's have a look at it. 98 students went on camp. They could choose from 3 activities: bushwalking, which we've labelled B, abseiling, which we've labelled A, and canyoning, which we've labelled C. Let's just have a quick look at this diagram and see if it makes sense. What do you think these 15 students did? All 3? Correct. What about these 3 here? These 3 did bushwalking and canyoning, but not abseiling. What about these 14? They only did bushwalking. Here's our first question. How many students did no activities? So we want to know what this number is. Just like before, we're going to add up all of these numbers and see how close we get to 98. Adding them all up, we get 86. So if we do 98, take away 86, we get 12. So 12 students did no activities. So now that we've got a full Venn diagram, let's answer some questions about it. How many students only did canyoning? So remember, we want the number that is sitting in the C circle, which is not in any of the other circles. So this one here, 14. How many students did bushwalking and abseiling? Now be careful here. We want these 10, but we also want these 15 because they did bushwalking and abseiling. The fact that they also did canyoning isn't important. So we want 25. How many students did not canyon? Let's think about that. We want all of them except for the ones that lie in this circle. So we want 12 plus 20 plus 10 plus 14. Adding them up, we get 56. How many students did canyoning but not abseiling? So they have to do canyoning, but we don't want them sitting in the abseiling circle. So these 2 here, so 17. Okay, here's a couple more. How many students did exactly 1 activity? So remember the ones who only did canyoning, that's these 14. These 14 only did bushwalking, and these 20 only did abseiling. So we want to add those 3 numbers up. So altogether we get 20, 30, 48. How many did abseiling or bushwalking? Now remember, this is an inclusive or. It doesn't say but not both. So we're going to look for all the abseilers and all the bushwalkers. So that's all of these guys and all of these guys. So we need to add up all of those numbers. What do we get? 62. And then finally, how many did abseiling or bushwalking but not both? There's our exclusive or. So we just want to take away these ones here. Okay, so we'll just take that 25 off the 62. Or we can add them up. It gives us 43. Okay, so we're finished with Venn diagrams. In our last lesson for probability, we're going to look at two-way tables.